So we have reviewed solving equations with one step, two steps, and multi-step. Now we're going to take a look at equations when we have variables on both sides. So there's just one extra step here to solve these. And for our first example, we have 4b plus 2 equals 3b. So we have 4b on one side and 3b on the other. Now, it really doesn't matter which one we move first, but I always suggest moving the smaller of the two, just because that alleviates us working with an extra negative sign. And the more negative signs we have, the more likely we are to make a mistake. So that's why I always suggest to move the smaller one first. So 3 is smaller than 4, so that's a positive 3b over here. So I'm going to subtract 3b from both sides. So I'm going to move it all at once. Now 4b minus 3b is just 1b, so we'll write a b. And then we bring down this plus 2. And 3b minus 3b leaves us with a nothing on that side, and that is okay. We just fill it in with a 0. And then for this one, we just have one more step. We have this plus 2 over here with the variable, so we have to minus 2 from both sides. Remember, we want to get rid of what's on the same side with the variable. So that would cancel, plus 2 and a negative 2 would cancel. We have b left, and 0 minus 2 would be negative 2. So b is negative 2 is my answer for that one. Now to check our work, we can plug this back in. So remember, you shouldn't have any questions wrong because you're able to check them. So they're saying that when we do this, we should get 3 times our negative 2. So 4 times negative 2 would give us negative 8, and then we have to add 2 to that, which would be negative 6. And then on this side, we have 3 times negative 2, which would be negative 6. So then, yes, that's equal to each other, so then we know we have our answer correct. Our next one here, remember, draw that upside down T through the equal sign. We have 0.3y on the right, or on the left, and 0.7y on the right. So 0.3 is smaller, it's positive, so we're going to subtract it. So these guys would cancel out. We have to bring down our 0.5. That's the only thing left on that side. 0.7 minus 0.3 would leave us with a 0.4y. And we also have to bring down that minus 0.3. Now, on the side where the y is, we have to get rid of the number that's not touching the y right now. So that's that minus 0.3. So we're going to add 0.3 to both sides. So we have 0.8 over here, and we bring down this 0.4y, and this would cancel out over here. And we have one more step. We have to get rid of that 0.4. It's being multiplied, so we're going to have to divide by 0.4 on both sides. And 0.8 divided by 0.4 would be 2. And again, we can check our work by plugging in that 2 for every y. So we keep this 0.5. 0.3 times 2 would give us 0.6. 0.7 times 2 would give us 1.4. 0.5 plus 0.6, which would be 1.1. And then 1.4 minus 0.3 would also be 1.1. So we know we have the correct answer. Moving on here, we have an equation with some fractions, which is okay. But we notice that we have that 1/2 outside of a set of parentheses. So the first thing we have to do is distribute that. So we have a 1/2 times b, which is just going to be 1/2 b. And then we have to do 1/2 times 6. So that would give us 3. And there's nothing to simplify on this side, so I'm just going to copy it down. Now we have a 1/2 b and 3/2 b. So 1/2 is smaller. So it's positive, so I'm going to subtract it from both sides. So it would cancel here, bring down that positive 3. And 3 halves minus 1 half would be 2 halves, which is a whole. So we have 1b minus 1 left for over here. And then I would have to add 1 to both sides. So 3 plus 1 is 4, and b left on that side. So b is 4 for our answer. And we can plug it in to check that out. Oops, not b, we want a 4 there. And because I have to multiply it by a fraction, I'm going to write it as a fraction. All right, so on the left-hand side, we have 4 plus 6 is 10, and half of 10 is 5. And then over here, 3 halves times 4 would give us 12 halves, and 12 halves would be 6, and 6 minus 1 is definitely 5, so we know we have the correct answer. Another one here, we have a positive 15 and a negative 9 on the left-hand side, because remember that equal sign is our barrier there. Those two numbers can go together. So I'm going to keep the 3x, and 15 minus 9 would be a positive 6. And then on the right-hand side, I have to distribute this 2. 2 times x is 2x, and 2 times 2 is 4. Now I get to move the x. I have a 3x and a 2x, so I'm going to move that 2x. It's a positive, so I'm going to subtract it. And 3x minus 2x leaves us with just 1x. Bring that plus 6 down. Our equal sign down. 2x minus 2x cancels. So we have just a positive 4 on that side. And our last step, we have a plus 6 with our variable, so we have to minus 6 to get rid of that guy. And 4 minus 6 would give us negative 2. And again, we can check our work. We're going to have to do 3 times negative 2. And 15 minus 9 is 6, so we can simplify that part. So 3 times negative 2 would be negative 6, and then we have that plus 6, so that would give us 0 on that side. And then over here, negative 2 plus 2 in the middle would be 0, and 2 times 0 is 0, so that is equal, so we know that is correct. Now we have a couple of vocab words. An identity is an equation that is true for all values of the variable. So that means no matter what number I pick, it will work in our equation. A contradiction is one that is not true for any value of the variable. So in other words, that's a no solution. So identity is infinitely many solutions because I can plug in every single number that we can possibly think of, and it will work. And then the contradiction is no solution. There is no number that we can plug in to make that work. All right, so example 3. Here's our barrier. We have a 4y and a minus y over there. So I'm going to simplify that. That would give us 3y, and then we have that positive 7. And we can't do anything over here, so I'm just going to copy it down. And then we have y's on both sides. They're both positive 3, so I'm going to subtract 3y to move. And they both would cancel out, and I would be left with 7 equals 10. That is not a true statement. Therefore, this is a contradiction. And there is no solution for it. All right. And this one, again, our equal sign, that's our barrier. I have a 2c plus c that are like terms on the left. So that would make 3c. And then we have a plus 7. On the right-hand side, I have negative 14 and a positive 21. That would leave us with 7 plus 3c. And if you look already, you can tell these are the exact same equations, just written backwards. But we can minus 3c from both sides. We can keep going here. And they both would cancel out, and we would have 7 equals 7. And that is true. So this is an identity. And there's infinitely many solutions. So we can plug in whatever number we want and it will work. All right, for our last one, I misspelled 4. 4 times Greg's age, so I'm going to write 4 times G, decreased by 3, so that means subtract 3 from that, is equal to, so equals 3 times Greg's age, so 3G, increased by 7, so that would mean plus 7. How old is Greg? So in other words, solve for G. So I have a 4G and a 3G. I'm going to move the 3 just so I don't have to work with negative numbers. So it's positive. I'm going to subtract it from both sides. And 4G minus 3G is 1G. Bring down that minus 3 that's left. These guys cancel and we have a positive 7 left on that side. And then I have to add 3 to both sides to get rid of that minus 3. So those guys would cancel. And 7 plus 3 is 10. So Greg is 10 years old.